population. Right now, we have 15 rats between 0 and 3 months, 9 rats between 3 and 6, 13 rats between 6 and 9, 5 rats between 9 and 12, 12 rats or 0 rats between 12 and 15, and 0 rats between 15 and 18. Okay. Question number 1 says, how do you find a new population distribution after 3 months, which is 1 transition? Why is 1 transition 3 months? 3 months have gone by in 1 transition.
Because it goes from 3 to 6, 9 to 6.
Look at all of your ages, 0 to 3. They're grouped in 3, so that means every 3 months is a transition. Okay, so we need to talk about newborn rats being born. So we need to deal with birth rates. Okay, so I have 15 rats that are between 0 and 3 months. None of those rats are having babies. Okay.
What's that, a 4 or plus?
That's a plus.
That's a plus.
I look like no.
I have 9 rats that are between 3 and 6 months. And 30% of them are having babies. So we multiply by 0.3. We keep going. I have 13 rats between 6 and 9 months, and 80% of them are having babies. I have 5 rats between 9 and 12 months, and 70% of them having babies. And I'm going to stop there because you have no rats in the other 2 categories. So if you plug that into your calculator, that will tell you how many newborn rats you have. Which is what? Somebody plug that into the calculator and get me an answer. $16.6. So we have 16.6 newborns. Okay. 16.6 newborns. Yes, I know it sounds weird. You can't have 0.6 of a rat. We'll leave it there for now. Okay. What, they have an extra leg and an extra tail? 2 heads?
Missing a leg.
Missing? Oh, okay. We have a rat that's missing some parts, so they're only 0.6 of a rat. Okay. You cut off the tail, chop. Okay. We can also find out how many rats move on to the next age group. So, 15 rats are in 0 to 3. 60% of them move on. So, to find out how many rats live to be 3 to 6 months, you would multiply the number of rats you have times the survival rate. So we should have 9. And these rats are now 3 to 6 months old.
9.
Okay? You do it with each one. So you have 9 rats and 90% of them live. $8.1. You have 13 rats and 90% of them live. 11.7. You've got 5 rats and 80% of them live. And you get 4. And then obviously if you have no rats to move on, both of these are going to be 0. So we can now write this table with our new information. I now have 16.6 rats between 0 and 3 months. I now have 9 rats between 3 and 6 months. I have 8.1 rats between 6 to 9. Okay, remember, these move on. So 9 was originally in 3 to 6, so 8.1 are now in 6 to 9. These ones move on to 9 to 12. These move on 12 to 15. Okay. So we've got 6 in the, or 8.1 in the 6 to 9 range, 11.7 in the 9 to 12 range, 4 in the 12 to 15 range, and 0 or between the 15 and 18 range. If they ask you for a grand total of rats, you would add all those numbers up. Okay. Okay. Now they want us to move on and use that information that we just had. So let me write that on the whiteboard here so we have it. So we had 16.6 newborn. How many do we have? 0 to 3? Huh? 9? And then what was it? 8.1, 11.7, 4, and then this was 0 and 0. Okay, so this was the information that we just came up with. They want us to do it again and see what happens after 2 transitions. Well, in order to do that, you have to use this information. So, again, I now have 16.6 rats that are newborn. And we know the birth rate. None of them have babies. Okay, we're still using the birth rate from the front chart. 0 of them have babies. I now have 9 in the 0 to 3 category. And 30% of them are going to have babies. I have 8.1 in the next category. And 80% of them have babies. 11.7 in the next category. And 70% of them have babies. 4 in the next category, and 40% of them have babies. And I'm going to stop there because we don't have any in the next category. So figure out how many newborn rats we have. 17 points. I got 18.97. Double check and make sure you didn't just miss putting something in. Make sure I didn't miss putting something up right. 0.3, 1.8, 7.7, 0.4. I could have just written it down wrong because I typed it in. Okay. 18.97 newborns. Okay. Again, we can find out how many move on. I had 16.6 to start with in my newborns, and 0.6 of them survive, which means how many rats move on to the next age group?
I mean, they want to look on that.
9.96. Whoops. 9.96. Move on to 3 to 6. Okay, I started with 9 in this category. 90% of them live. 8.1. I started with 8.1 in this category, and 90% of them live. 11.7 in this, 4 in this, and 0 here. So you should have ended up with 7.29, move on, 9.36, 2.4, and none.
Question. How did you get those numbers on the right side? In the green.
Multiply how many rats you have by their survival rate to get that. Okay. So we multiply here. Okay. And again, we can write yourself a distribution table. I've got 18.92 or 97 newborn, sorry, 97. I now have 9.96 in the 3 to 6, 8.1 in the 6 to 9, 7.29 in the 9 to 12, 9.36 in the 12 to 15, and 2.4 in my 15 to 18 category.
So they're dying out or what?
I mean, yeah, I guess all the numbers have gone down. My original numbers were,
15 now.
yeah, we're dying out. I mean, your newborns are getting bigger because we started with 15. Your newborns have gotten bigger. This has gotten bigger. We started with 13 here, so we're really dying out there. We started with 5 here, it's getting bigger. I mean, we are actually gaining more rats than what we originally started with. The only one that went down was this one. All right, the next one we're going to look at is a deer population. We're going to look at a deer population. Okay, so find the number of newborn female deer after 2 years. How many transitions is 2 years? Just one transition, okay? Every 2 years. These are 0 to 2 years old, 2 to 4 years old, 4 to 6. So 2 years is one transition. Okay? We need to find newborns. Same process all over again. Any deer that's between the ages of 0 and 2 years cannot have babies. So we have 50 deer that can't have babies. I have 30 deer, and 80% of them can have babies. I have 24 deer and 1.7. Okay, so that's saying that deer have more than one baby within those 2 years.
0.7.
Okay, 24, and they also have a rate of 1.7. My 8 to 10 deer have a rate of 0.8, and my eldest deer have a rate of 0.4. Okay. Mostly your deer die off somewhere between 10 and 12 years.
They still be sticking to move.
Okay. But what did you notice about deers that rat can't do? Deer can have babies their whole entire life.
They keep on going when they about to die. They don't care.
Into this chart they can.
I mean,
40, I don't know how true this chart is.
Just keep on. Where you going? Where you going? Now, don't run, girl. No. That's what you be saying, baby.
Like a marker?
Are you on your phone?
Yeah. Why does someone need pen?
It's for the braided thing. The little pastries.
I just think he's actually that's what it is.
Okay. So, how many newborn deer do we have? You said what? This comes out to be 77.6. That is not what I got. I got 111.8. You got 118.4? Let's go with 118.4. Because I don't feel like plugging it back in. I don't know. I have a 111.84. Okay. Now we can calculate the number of deer that survive in each age group after 2 years.
Wait a minute, that's a big number.
118 newborn deer?
It is. I got that many kids.
Get that overpopulation.
Okay, so you've gotten the point. This is a long and grueling process to do by hand. Okay, so let's skip all of this and let's go to the easy. Okay, you ready? No, you're going to need your calculator. Yes. Once I show you how to create this Leslie matrix model, we're going to actually skip this page too. go to this one. This is where I teach you how to do it the simple way. The Leslie model is computationally tedious. As you saw, we had to do the newborns, then we had to do each survival group, blah, blah, blah. The Leslie matrix is a square matrix that uses the birth and survival rates of a population, such as the rows will always represent the different age groups, and the columns, the first column represents your birth rates, and your other columns will represent your survival rates. Okay, so we are now going to create a matrix that will do all of that fancy computations for us. So here we go. What is the initial population and Leslie matrix for the fish? So we've got, oh, they're using the other problem. If you look back at, where is it? They're using the fish problem on the page right before this. Okay, so they're getting their initial populations from that chart. Okay, so they're saying we have 60 fish that are between 0 and 5 years. Okay, we've got 80 fish between 5 and 10 years. We've got 100 fish between 10 and 15 years. And we have 80 fish between 15 to 20 years. Okay, this is your population matrix. We now have to create a Leslie matrix. Okay, so Leslie matrix. Your first column of your Leslie matrix will always be every one of your birth rates. So if you looked at the chart on the page before, all of your birth rates for your fish, 0, survive or have babies between 0 and 5 years, 50% or 0.5 of my 5 to 10 year fish have babies, 0.80% or 80% of my 10 to 15 year olds have babies, and 0 of my fish between the ages of 15 and 20 have babies. Okay, so this first column is always your birth rate. Okay, it's the survival rates that are going to cause you issues. So you have to be very, very careful when we do this. Okay, so this column, this represents 0 to 5, 5 to 10, 10 to 15, and 15 to 20. This second column, we're talking about survival rates. So according to my chart, 0.6 of my 0 to 5 survive. We want to do that as a separate entity. So everything else is going to be a 0. Okay. Your next column, you have 0.9 of the 5 to 10 that survive. So we need to go down 1 row and fill the rest in with zeros. Okay. Your 0.9 go with your 5 to 10 babies. Okay. And then we have 0.9 of these, the 10 to 15. Again, make sure it's in the proper row. And none of these ones survive, so we can stop there. That is a Leslie matrix.
Wow. Everything.
No, we have to multiply them now. This is the setup. We now have to multiply. But now that we have this, the multiplication is easy. So please go ahead and put this in as matrix A in your calculator. Put this in as matrix B in your calculator.
Hold up.
Hold up what?
Never mind.
So again, the hardest part is going to be coming up with this matrix and making sure your numbers and your zeros are in the right spot. And the second hardest part then is going to be taking the time to plug it all in and make sure everything's right. Once it is in, it is easy peasy lemon squeezy. Yes, ma'am. So this would be newborns or 0 to. Okay, I see what you're saying. These are all ages. So it's gonna be the same thing across the top, because you're just dealing with flat out ages and no other mixture in there. So this is 0 to 5, 5 to 10, 10 to 15. Go ahead. It's also 0 to 5, 5 to 10. Okay.
Go like this.
That looks good. Okay. All right. So if you only need one transition, P sub 1, that means one transition's happened, which means 5 years have gone by. Because remember, your ages go from 0 to 5, 5 to 10, 10 to 15, 15 to 20. So 5 years have gone by after a transition. You would take A and multiply it by B. And Alonzo, what did you have?
120,
120,
36,
36,
72,
72,
90.
90. Okay. So after 5 years, I now have 120 fish between the ages of 0 and 5, 36 between 5 and 10, 72 between 10 and 15, 15 to 20 90 between 15 and 20. Okay. I now want 2 transitions. So you can always go back and multiply and do it twice. Or take your original, so matrix A, times matrix B raised to the second power, because you want 2 transitions to happen. And that will do true transitions for you instead of you multiplying and multiplying and multiplying. So what do we get here? And yes, there should be decimals.
75.6,
75.6,
72,
72,
32.4.
32.4,
Oh, yeah, 64.8.
and 64.8. Okay, so every time you want a transition to happen, you raise it to whatever transition you want to happen. Okay, so 2 transitions in this example is 10 years, because every transition is 5 years. Okay, so go ahead and do 8. Your 3-year transition. So instead of raising it to the second, this time we're going to raise it to the third.
So you know what says P2? That one? Does that even matter?
That's just saying you want the second transition. The P sub 2. P sub 3 means you want the third transition. Okay. What did we get for this one?
61.9. No, wait. Yeah, 61.92.
If you scroll over, you can. Use your right arrow key.
45.36. 64.8. 29.16.
Yeah, not all of your answers are going to be pretty and just fit on your screen. If you cannot see it, use the right arrow key to scroll over and it will show you everything. Okay, so this next part, they just want you to use the equation. So you take your initial population, which we put into your calculator as A, and you multiply it by your Leslie matrix, which we put into your calculator as B, and you raise it to the n. And n represents your number of transitions. Okay. Like I said, it's easy peasy lemon squeezy once you get the setup of the Leslie matrix and it all plugs into your calculator. Are you alive, Emma? Okay. We're going to do one more. Okay. And then the next 2 or 3, you guys are going to work on when you come to class tomorrow. Okay. There's not enough time to do it today, and I don't expect you to try to do this without a calculator. It's insane.
So what do we do?
Okay. Actually, you could probably at least get the Leslie matrix and stuff set up. Or how about this? Try to do your initial and your Leslie matrix for the next one on your own. Set up the matrix. Okay. If we can get the matrix. Okay. So this chart that they give you will be your initial population matrix. This chart at the top. And then you use this to create your Leslie matrix. Okay. Try to get it written out.
As soon as we hit the first zero, we can stop, right? We don't have to put them in the matrix.
As soon as you hit this last survival rate, that's an actual number. No, you need all of that.
Oh.
You cannot skip out on that. Do not skip out on any of these numbers for this. So your population matrix has to contain every number that they give you. Okay. So there's your initial population matrix, which we like to call A in our calculators. What's my transition period for this while you're working? 3 months. Every 3 months is a transition. Okay. They like to use the word cycle to represent transition too, so please do not get confused if you see cycle instead of transition. So I really need to go back to your chair because this is not working for me. We do not need to share that. This is where you're going wrong. 0.6 goes here. So we're going to zeros. This moves over 1. So we're going to zeros. It has to be in the appropriate column. Like that. That's the catch. Okay, so my Leslie matrix, what should my first column contain? All of my birth rates. So 0, 0.3, 0.8, 0.7, 0.4, and 0. Okay. My next column should only contain my survival rate for 0 to 3. Okay, so that should go here. Everything else should be a 0. So this should be your 0 to 3 survival rate. The next column should contain your 3 to 6. Make sure it's one step down though. You don't want it up here with your 0 to 3. You want it down here with your 3 to 6. Fill it in with zeros. The next column is my 6 to 9. Again, make sure it's in the right position. The next column is going to be my 9 to 12. So each time you fill in a survival rate, you're moving down one row. Okay. So then 0.6 goes here. And once you put in that last survival rate that's an actual number, you can stop. Okay. So your Leslie matrix should look like this. Again, make sure these are stepping down each time you do a column. Go ahead and finish the questions that fit with this. So enter these both into your calculator. So we can do 1B, 1C, and 1D.
I'm gonna go there with.
Are you done with this?
Oh, my bad.
Okay, if we're doing 2 cycles, you would plug this in as A times B to the second power. Perfect. A times B to the second power. Plugging these in to make sure that you can do it correctly, because come test day, I will not answer any questions on how to plug these in. Who's got an answer? Anybody yet?
18.97.
18.97.
9.96. 8.1. 7.2.
9.36 and what?
2.4.
2.4. Who had something different? It could just be a simple thing in your calculator, but what the hell? That's all. Matrix.
Ms. Smith,
Yes, ma'am.
can you send Lacey Ann Cyber to the office signing out?
Sure.
Thank you.
Did anybody else get anything different? 0.9. That's your problem. Right there. You did too many 0.9s. This should have been 0.8 and 0.6. It's usually a calculator error. Okay. Roll fast, let's get the answers for this. 24 months is 8 cycles. So A times B to the 8th power gives me what?
What number do I round it to?
I do 2 decimal places.
21.02,
Okay,
12.28,
okay,
10.90,
okay,
9.46,
okay.
7.57, and then 4.27.
Good. Okay. And finally, these last ones, I don't need answers. How would I calculate P sub 25? What would it look like when you plug it into the calculator? A times B to the 25th.
Yeah, yeah.
Okay, we would do A times B to the 26th and A times B to the 27th. Thank goodness we have Leslie matrices to do this, or else you would have to do this over and over and over again 27 times to get those answers.
Are we gonna do the,
Okay.
Are we gonna do the correct?
So-
On the,